couple days ago, I demonstrated the use of this device. It's called a Pythagoras cup or a greedy cup. And what happens is when you overfill it and the water goes or the liquid goes over the top of this bend, you create a siphon and it drains the whole cup out. Many people were wondering if I could do a little bit more about how siphons work. And the interesting thing is they really do not work the way that most people think. Of all the things that people have misperceptions on in science, the siphon might be right near the top. So let's talk about how a siphon actually works. So what I've got here is just some dyed water so you can see it better sitting up on a beaker, and we're going to create a siphon here. So I've got a clamp on the hose just to slow down the flow, and you'll see why in just a minute. So let me pull the air out of the hose. And when we pull the air out of the hose, we've created the siphon. You can see that it starts to flow. So the question is, will a siphon work in a vacuum? So let's take a look at that. The common misperception is that it's air pressure pushing down on the liquids that cause a siphon to work, but the reality is they will work in a vacuum, which most people don't think is true. So let's take a look at that. I got it ready to go. The reason for the clamp is to slow down the water so I can get the vacuum going. So here it is, it's flowing. We'll get that on, turn on the vacuum. And you can see that even in the vacuum, the siphon flows. Now this is not a full vacuum, but it's pretty darn good. There are videos online of people doing siphons in complete vacuums, but you can see that it's still working. So what's really at play there if it's not air pressure pushing down on the liquid? Well, it turns out that it has more to do with gravity and the cohesion and surface tension of water pulling it down out of the beaker, but it's not air pressure as people believe. Now you can compress air and make the liquid move, but that's not the case in a standard siphon. The more you know.